Uh, what can I say? So now we were talking a little bit about human-made issues to ecosystems, how humans have been impacting ecosystems in the recent years. So yeah, let's go ahead. Oil. Uh, so if we talk about oil, a lot of us might have heard oil, but the original word oil, the word oil refers to actually the crude oil, which is the original remains of plants and animals that have been compressed under the under the earth's surface, and have transformed into what is today called as oil. We also term them as fossil fuels because it's generated from fossil of animals, and we're using it as fuel. And this crude oil is, you know, major source of uh, wide range of products and different range of fuels. For instance, petrol, diesel, kerosene, several different types of fuels we use in different type of vehicles. Similarly, we have other products like, for instance, tar, that is also bitumen, which is used for laying roads. Most of the plastics are derived from products that are, used that are generated during the refining of crude oil. And we have wide range of products that are generated from this crude oil. So most of these oil is trapped under the surface, as I said earlier. This can be either now this can be you can extracted from on the land or under the sea. So you can find these oil reserves on the land and under the sea. So most of these land-based reserves, if you talk about Middle Eastern countries, most of the oil reserves are from land-based reserves there, and we have a lot of marine-based oil reserves also. So yeah, so when we extract oil, basically this crude oil, there's a high chance, that we end up spilling because even we are humans after all. We make a lot of mistakes, and one of those mistakes tend to be this spilling of these oils. Even whatever greater care we take for these oils, we end up spilling them. So, so oil spills here here refers to the release of crude oil or refined petroleum products. It can be the crude oil that is, whatever you are extracted. If that spills up, that's also termed as oil spill, or refined pet, refined petroleum products like petrol or diesel. These are refined petroleum products. If they also spills, they are also referred to as, you know, uh, oil spills. Just give me a minute. Yeah. So that's the thing about oil spills. Going ahead. So how all these oil spills happen? There are different ways these can happen. Uh, Basically, you can group them into broad categories. One can take from the small scale oil spills. Basically, here the oil spill happen mostly during refueling of vehicles mostly, but most of these oil spills here, the refueling based spills happen majorly in sea transport, like refueling of ships. That will be slightly a spill, and leakage of leakage of vehicles that transport or the vehicles that are carrying oils. So that also leads to oil spills. But these are small scale oil spills. Uh, what about large scale oil spills? So large scale oil spills happen especially when we have break in uh, pipelines. For instance, these pipelines which transport oil from from a place where it's produced, where it's extracted. So not produced, where it is extracted to refineries, or from refineries to filling stations from where it is uh, it is distributed. So that can be one way it can happen, or the other possible is like oil tankers. So oil tankers, they carry a lot of fuel across, you know, across the ocean to different countries, from different regions to different regions. So if an oil tanker sinks due to a lot of issues, like it can be rough seas or it can be some mechanical failures or whatever reasons. So that will lead to a lot of spill, because all the oil that the tanker is shipping, basically ends up in the ocean. Uh, and drilling operations. So especially when these oil explorations are going on, what happens is, so you will be looking out for places where oil can be found, right? So as you're trying to probe around the earth with your drills, you might end up, when you're not prepared, or when you are, you know, uh, you end up finding oil when you're not expecting, or you know you're not managing your operation properly, then there is a high chance that this- there is a spillage of oils from the drilling operations also. And obviously, the last thing, sabotage. Sabotage basically where purposefully, as humans, we end up putting out a lot of this oil into the environment. So most of these things are, might be related to oil spills, but it can be related to other type of spills also, like yeah, natural gas also. Uh, so, so most of these spills are most common in marine environments, because that's where we tend to find a lot of these oils, or the environment that we use majorly for transportation of oils, right? So that's where most of the spills occur. But there, on the land also, there is a lot of spills that occurs also, which the scale might be relatively small on the terrestrial environments, but the scale and the effect that it leads to is much more visible in the marine environments. So for instance, this is a satellite image captured by NASA of an oil spill in Gulf of Mexico. So yeah, this the scale of the spill can also be viewed from the satellite. So it is really such a huge thing. So let's just have a look at data from, since we're just saying that marine spills are the most higher ones. The spills mostly happen majorly in the marine environment. So and most of these spills is contributed by tankers also. And if you just look at oil spills by tankers from 1970 to 2022, you know, there has been a reduction in the amount of oil that has been spilled up by tankers. It's, for instance, in 1970s, there is more or less 3,000, somewhere around 300,000, or basically 3 lakh tons to 4 lakh tons of oil being spilled up into the ocean. But if you look at 2018 to 2022, there is little. And 2019, 2020 are basically COVID years, so there was little transportation around. That could be the reason why we are seeing very little spills there. So 21, 22. relatively less when compared to what used to be there in the 1970s. Uh, Same thing. If you just split this graph into the magnitude of the spill, whether the spill is so the spill is then the amount of oil spilled up by a single tanker versus if it's small, we can call them as medium oil spills. The amount is 7 to 7 tons. If it's greater than 700 tons, it's large oil spills. So if you look at it, you know uh, the medium oil spills have reduced drastically, but large oil spills also reduced. But compared to medium oil spills, not that much. So there is both contribution from medium oil spills and large oil spills to these spills, especially from tankers. If you try to look at what could be the reason why these tankers, are there is this spill happening from these tankers. So mostly, if you look at proportional, this is a proportional graph. So for medium and large type of spills, it can depend upon the capacity of the tanker also, the medium and large, or the amount it's transporting. Yeah. So if you look at what are different causes that can lead to spill, so one is it, collision with other ships, fire or explosion in the ship, hull failure is basically the structure of the ship itself breaks up due to other things. Can be weather related stuff or any other related stuff. Unknown, not attributed to anything. Equipment failure, some critical equipment failure can lead also to uh, tankers getting involved in accidents and leading to spillage. Grounding, where tankers uh, end up in shallow waters and then they get grounded, so they can't really move, and then that thing damages the ship structure, and then that might lead to leakage of oil and other causes. So if you look at it, most of it is due to either collision or grounding of the ships for both large and small. And equipment failure is relatively higher for medium-sized spills, while hull failure and fire are relatively higher for large type of spills. So yeah, so there are multiple reasons that is happening, and then collision and grounding are major causes. And then the the reason why these have been reduced the oil spills is because we have better navigation systems these days that might have reduced in most of these things, but there are still other factors that that we can't really necessarily avoid. So that might be leading to a lot of spills that we see these this also. Yeah. So the location at which the ship was present uh, when this incident occurred. If you look at large size ships, uh, it could be either anchor when it was anchored, refueling, underway when it's traveling, a tanker, open water, it's stopped in the open water, loading or discharging whenever it's taking in oil or take, pumping out the oil. Inland when it's coming into, mostly travel passing through channels or coming into the port. And so if you look, most of medium sized were due to uh, most of not found what could be the reasons, and few are due to when traveling in narrow channels and other reasons which are not attributed as of now. And similarly for large, most of it is when it's in the ocean and it's anchored, and there is little amount when it was taking in taking in oil for storage, and also when it was pumping out oil. So these are the areas, if you can stop them from spilling, you can reduce the amount of oil spilled by these tankers. So we all know that the spillage is happening. So we all might have heard or seen in news that it harms life. So how does it harms life? So it can harm physically, which is termed as fouling or oiling. It can be either it can be plants or animals. Okay, so for instance, how does it harm? So if you look at oil coat, it forms an oil coat. For instance, if you look at birds, if they end up in water, like the birds like uh, pelicans or boobies, which dive into the water for catching the food, which is fish. So once they dive into the water, when the oil floats onto the water, once this bird dives in and comes out of the water, so their whole body gets coated in this oil, and then that leaves the body of the bird, you know, uh, unflyable. So that unflyable bird just sitting in the water, it can die of exhaustion or it can be preyed upon by other fishes in the water. So yeah, that's how it can die. And similarly, uh, it can take the insulating performance of the fur and the feathers. So most of the fur and feathers, most of these animals have the insulating. Their role is to insulate the body from heat or cold or other elements. So they lose their functions, especially if you look at like examples like sea otter and penguin. Sea otters, them they're found insulated in cold waters, and then feathers also have, or the fur has, a relative higher role in maintaining the body temperature along with the fat. So if the feathers are coated up in oil, they may not be able to trap those air particles between the feathers to effectively uh, you know insulate the body of the organism. So it can harm it in that way also, and it can lead. And the other way it can harm life is oil toxicity. So as we are saying, oil is consists of hydrocarbons. So if you end up ingesting or if you come in contact with most of these some of these hydrocarbons, they can lead to toxicity for the organism, and that can harm life. So that is oil toxicity. So yeah, let's just have a look at some of the cases where oil spills have happened, and it has how it has how it has been. Case studies of how oil spills have happened, how things have progressed because of that. So for instance, uh, let's talk about a case of uh, terrestrial oil spill. So in 1991, the Gulf War was fought between Iraqi and Kuwaiti forces. Uh, Once the Iraqi forces were quitting from Kuwait, uh, what they did was they left most of the oil pipelines and wells of oil open. So most of these, if you remember, so terrestrial oils extraction has something like this: is pumps. So they'll be moving continuously, and then they'll be extracting oil, and then these wells have to be sealed so that since these oil resin pressurized between the rocks, you have to seal them when you are not extracting them. So if you don't have proper closed wells, they might lead to leakage of the oils. So what these forces did was uh, in the, because of some conflict going on between them, the Iraqi forces, when they were quitting the invasion and going back, they opened those wells and they set them to fire. So they just burned them. And this thing, the effect of these things lasted for 4 months. Basically, most of the oil was burned. Then most of them was able to stop only when there is no more oil to burn. So yeah, more than it is estimated that more than 200 million gallons of oil was thrown in the Persian Gulf also. So there's both terrestrial and then marine spills that have happened, and this is sabotage way of spillage, oil spills that have happened. So yeah, so this is a common phenomenon. This is a phenomenon that happens, when things like this happen. But it's generally rare to have, sabotage level at this larger scale. So yeah, it leads to it damages the environment pretty much. And then there are a lot of movies made with this scenario in the backdrop also. If you are interested, you can check them out also. So it just describes how these wells just spray up, this oil, and then they just keep on burning. So going ahead, one of the let's talk about one major marine oil spill that has captured the whole global attention, and then it's a really interesting case. So Deepwater Horizon oil spill that is in you know uh, Gu- Gulf of Mexico, which is the image that I was showing earlier. This image is a spill from this Deepwater Horizon. So what happened here? So this oil spill started on 20th April 2010 off the coast of United States in the Gulf of Mexico, uh, where there were this prospecting for oil presence in this gulf. So they were drilling up in the ocean. Right. So when they are drilling, this accident happened, and then that lead to spillage of uh, oil. And then the U.S. in the end, estimated that somewhere around 210,000, basically 21 crores US gallon, or 780,000 cubic meters of you know wait, yeah, this much amount of uh, oil has been spilled into this ocean, which is such a huge amount of oil. And it's also regarded as one of the largest environmental disasters in the world is there. So it is such a huge spill that has happened. And so let's talk about what has happened. So this is how a submersible, or how this oil prospecting or oil extraction operations in the ocean goes. So most of these are submersible, semi-submersible, so they can submerge to little depth and then maintain their balance. Or else most of these are floating. It's like floating cities in the middle of the ocean. So they can be transported to any places, and then they will start drilling for oil when you are searching for oils. So what happened was, this Deepwater Horizon is one such semi-submersible floating rig, drilling rig. So its main job is to drill and set up this equipment for the extraction to happen. So it can operate in waters at 3,000 meters deep. So what happened on April 20, 2010, which is like 13 years ago? Uh, High pressure methane gas from the well they were trying to dig rose up into the rig. So it just came up because it has been trapped for millions of years sometimes. So once you try to make a hole between these pressurized elements, either to be gas or oil, it just comes up. So once this gas came up, and since methane is one of those highly inflammable gases, and exploded, it just caught fire. The whole platform caught fire, and once the platform caught fire, there was no way they could stop. They were not able to seal those wells properly, and then whole of the platform got submerged. And they tried to stop the well by blocking it in some other ways, but by the time they could do that, the oil flowed for 87 days. And then yeah, it made that oil spill resulted in the world's largest accidental spill. It's not deliberate, but it was an accidental. So what happened aftermath? The whole beaches around that area were having oil, as you can see from this outline. So all this is oil that has washed up shore because oil is lighter than water, it floats, it just comes up. And this is how it can be seen. All these boats that you're seeing are trying to remove the oil from the water. And yeah, this was the area where it has that thing eventually sank once it burnt up entirely. So yeah, a lot of wildlife is also affected around that area, and this is one such example of this turtles, completely immersed in what oil. So what happened? So they had to clean up. So there are different methods that were used, especially or are generally used for cleaning marine oil spills. So mostly, uh, major method is first thing they do is once you have specific amount of spill that is that's no longer coming. But since oil floats on water, they keep floating foam. So basically, there is a floating devices that are kept that enclose the whole area where the oil has cupped. So that prevents it from spreading more, and then the other cleanup methods can then come up. So the ships can that are taking cleaning, they can either take in the water with with the oil in it, and then separate them, or just take out the top layer of water, send it to onto the land to properly remove the oil from the water, and then pump out the water again. Or you can use chemicals termed as dispersants, that eventually break oil into much smaller particles. So what happens when the oil is much broken into much smaller particles is it mixes with water more easily. So what? So for instance, if you have done this thing, like if there is what oil floating on top of water or on a glass, uh, or else if you have had buttermilk with all tadka around, so you might have seen oil particles floating on top, or a oil layer if you have left it undisturbed. But if you start mixing it, the all those particles break down, the layer breaks down, and then you can see tiny bubbles mixed up in between. So what these chemicals does is like does some sort of similar job. Basically, they break the whole oil into smaller particles so that it can be mixed up into the water easily, and then it prevents from again from forming these much larger patches. So once they do that, it will be easy for either the oil to evaporate, or sunlight to degrade the oil, or bacteria can degrade these tiny droplets much more easily rather than these huge layers being degraded. So that's what dispersant do. And then removal. So you manually remove most of this oil. So this is how it happens. So this is what has been done during, I think, during this oil spill we are discussing currently. So wellhead is where basically this is the bottom of the ocean, floor of the ocean. This is all the ocean water, and then you dig much more deeper in the ocean floor also. So on the top you have dispersants. You basically spray it onto the surface that has come arisen up because oil rises from the bottom, and then it can rise straight. And there are few waters, few particles, that are carried away by air water currents and then rise up somewhere else. And then similarly, there is so what we do is you can have dispersants being pumped up near close to the wellhead from where this oil is actually coming out. What happens if you do that? The oil gets broken down there itself, and then it is it just doesn't come onto the surface, and then stays very much in the water column, and then is carried away, and then eventually hope for it to be broken down by the action of bacteria. So that's what happens. So if it can be contained by this way, there is no surface leaks that are seen. Basically, the oil coming onto the surface and forming this huge layer of oil on the water. So yeah, this is such one such thing in action, the aerial dispersal. This is the oil slick that you can see the brown shade. But there are concerns about using dispersing agents for oil spills. Uh, some of those agents that are used are in turn much more toxic than the oil itself. If although it breaks, if it's you know stays there for long, it can cause issues in the environment. So that's a major concern itself. Uh, yeah, so that's one thing. But one of the issues that we have created, oil spills. So it just doesn't stop there itself. From but you cause environmental issues when you are producing oil from to when you are using oil. So yeah, so it's not easy, you know. And then the other thing is plastic. So we use this oil, we refine them, we generate some chemicals, and then we use those chemicals to produce, you know, plastics. Now everything our life, most of the days our life revolves mostly around plastics. Maybe it can be the phone that we carry, to the water bottle we drink water in, or the plate we eat in, or anything that we do. Most of them revolve around plastics. So it has become, such an integrated part of our life, and so we made sure to integrate it into the web of life and into the life of every other organism. Not in a good way, but in a bad way. So, for instance, if you see this is a fish, it was supposed to swim around in a readily clean water, but most of it has these microplastics and nets, all this waste floating around. So yeah, life is not easy for them because of us. It's supposed to make life easy for us and also for others. But it's not how we are moving ahead. So most of the plastics we create, we just throw it up, right? So where do we throw? So we either have dedicated garbage dumps in urban metropolitan cities, or if you're not from the urban area, you might have witnessed most of these dumping areas close to small river, or small stream. So what happens? Most of this, when the water overflows or once the garbage level reaches a certain height, it just goes into the river, and then it just flows around, eventually goes up into the ocean. That's where all these marine organisms or the riverine organisms are getting affected because of plastic. Because we are not stopping ourselves from throwing them into the water bodies. So once in the ocean, so what they do is they move around in the ocean, and then since we have ocean currents, so they will not be simply sitting at one place once in the ocean. They will be traveling around with the current, and these current forces, ocean current forces these garbage or the waste that we have put up in the ocean into specific regions, and then these regions are called garbage patches. So one of the such famous and the biggest garbage patch is, you know, Great Pacific Garbage Patch, or Pacific Garbage Patch. So it's between US and Europe. Sorry, in the Pacific Ocean, very close to the US, or the North American region. So yeah, and then it's not the single uh, garbage patch. We have multiple garbage patches. There is another one called South Atlantic Garbage Patch. There is North Atlantic Garbage Patch that forms between US and the Europe in the Atlantic Ocean. So yeah, so there are a lot of garbage patches, but the distribution of these garbage patches are majorly determined by the ocean currents. So Yeah, let's just have a look at this video, that explains the Great Pacific Garbage Patch, so which is in the Pacific Ocean, close to the United States. Yeah. Uh, so yeah, so just watch in this video where they say, there approximately the estimates are around 80,000 tons of plastic waste. So that's really huge. And then the area, it's 1.6 million square kilometers. It is distributed along this, and then most of this is large part plastic, but there are tiny plastic fragments also involved, and that are the that are some problematic. So this video was made by this company called Ocean Cleanup, which is trying to clean up this Great Pacific Garbage Patch by you know by itself, and with help from others. But yeah, so it's such a huge problem of what to do with this plastic. Uh, so yeah, that's about garbage patch, and there are many such garbage patches across the world. So it's the major one because the plastic that is dumped from that region has ended up into that region predominantly. So that we are able to see it these days. So how does it affect wildlife? Most of this garbage that has ended up in the ocean can affect wildlife in predominantly two ways. One, one can be the effect due to ingestion of it, and another one is by entanglement. So if you look at entanglement, it harms creatures like turtles. For instance, if you talk about turtles, they have to come to the surface to breathe. If they are entangled in a net at the bottom of the ocean, they will eventually. go out of breath and basically drown. And even other animals, if they are entangled, they will not be able to move from one place to another. Even animals that don't need, you know, uh, a regular resurfacing, or the ones that can breathe, if you talk about large fishes like sharks, so they may not need to come to the surface for breathing. But if they got caught up in the net that was left out in the ocean, they are effectively dead eventually, because they are not able to feed. They're not able to do their normal duties, like they're not able to reproduce, they're not able to escape from predators, so on. So this problem comes especially with nets, majorly with nets, entanglement comes, especially. So the term for these type of nests are called ghost nets, just because whether they are damaged or they are lost in the sea, so they people don't regularly proactively go and search for them, so they're just lost in there. And then these nets are still active in terms of they have the capacity to catch whatever comes into them. So a lot of marine animals die because of this entanglement. And even dugongs, which are such a rare species to find in the Indian waters, lot of reports come because of their entanglement. Even when the entanglement happens in front of in active nets, uh, you know, it's easy to cut the net off and then let the animal die, rather than free the animal in most cases. So most of the people might end up choosing that option also. So that's how just a case of entanglement nets. So there are other type of plastics in which the animals can also get entangled into. For instance, a fish, if it ends up into a water bottle, it just grows and then dies in that itself. And the other thing is ingestion. Basically, here the animals end up injecting plastic particles into themselves. So it can be marine, it can be terrestrial, so on. You might have seen the picture in the class lecture where the elephant dung had rhino dung had plastic. You have been seeing, the dung of cow, which feed regularly in the garbage bins with a lot of plastic or garbage in it. So those are large scale plastic. But if you go into marine environments where there is a higher chance of finding microplastics. So you see a lot of microplastics in their bodies there. So which are smaller in size. Microplastics are basically plastic particles that are in smaller in size, or the larger particles that are broken by action of elements. So ingestion and entanglement are major problems for wildlife with respect to plastics. So if you just look at different type of plastics, or basically the ingredients of plastics, so they range from polyethylene to polyurethane, polyoxymethylene, polystyrene, polyester. There are a lot of plastics. So how often, if you look at what are these plastics are used for, if you look sorry, polyethylene are majorly used for storage. Either it could be plastic bags, or it could be water bottles. Are most are majorly made of polyethylene, or yeah. And then utensils, the plastic cups, plastic plastic spoons are made up of polystyrene. And then we also know of polyamide, which is basically nylon, while acrylic is used in paints. So one form of polyethylene is polyethylene terephthalate, which is what called PET, which is used for drinking water bottles. And then yeah, there are different ways these plastics are used. And if you look at what is that is that ends up into the ocean predominantly, it's polyethylene, polypropylene, polystyrene. So these three four compounds are some things that end up in the ocean more frequently. If you try to ask why, it could be, the simple answer could be, it's like these are the ones that are frequently used or produced in uh, you know huge amounts. So that could be the reason why they're finding huge amounts and there. And then yeah, the other reason could be, shorter lifespan. So yeah, there can be other reasons also. It comes up to us how we react, we use those substances. Uh, so with this case, let's talk about another case of uh, case study of how, you know plastic and oil spill together cause a disaster because of uh, the ship sinking. So MV Pearl Press Pearl is, is a ship that was from Singapore, based in flag container ship. Basically, it had Singaporean flag listed in Singapore. It's a container ship. It was, recently made, and it was commissioned. Almost, I think, 1 or 2 years. It's not an old ship. It's a relatively new ship. And what happened was somewhere on May 20, 2021, it reported smoke when it's in Colombo, which is Sri Lanka, where it was anchored. So on May 21st, there there was a visible fire on the deck that happened. And then the thing about the ship is it was carrying somewhere around 25 metric tons of nitric acid, and simultaneously it was also carrying, you know uh, plastic pellets that can be used to make other forms of plastic. And and then it was in the port, it was getting fuel. So there's a lot of oil, fuel that was present in the ship also. So what happened to this was, after the fire broke out, it burned. There were efforts to, uh, drag the ship back into deeper waters, because this thing happened on the shore. So if it's in deeper waters, it will be easy for them to, control most of those things. So they tried, but it sank in between. It couldn't go into much deeper water, so it sank it into a deep depth, where the depth was, 20 meters. And where it sank, there was this group that was, given this contract to salvage the ship and then remove the ship from there, because it's in the port also, and then it's also an environmental hazard. So they eventually had to cut the ship into three different pieces and transport it to different areas. So this is how it has happened. What has before left of the ship before it sank, and this is where it has happened, somewhere near to close to Colombo. So it's recorded as, the worst maritime disaster in Sri Lanka's history, because it was carrying a lot of, hazardous chemicals such as methanol, nitric acid, caustic soda, and it's also carrying a lot of plastic pellets that was about to weigh 1,680 metric tons, which is a huge amount. And then yeah, there were other chemicals also on the ship. So once it's caught fire, it eventually ended up in the ocean. Most of the chemicals or the things that it was carrying. So what happened? So to the environment. So there was a lot of evidence that, these things has impacted the environment. Like, research team discovered uh, biotoxin close to sunken ship produced by algae when they are as a response to some of those chemicals that are produced, but that are released from the ship. So they also found a biotoxin called saxitoxin, that is, that's a neurotoxin for you, that acts as a neurotoxin to humans and animals. So it it is leading to, chain of events that uh, the chemicals releases that might harm a lot of other animals indirectly also. And if you see this picture, what you can see is most of these are plastic pellets. See, uh, what I'm circling is a plastic pellet. And then if you see the gills of the ship, sorry, fish, have pellets attached into them. So what what can it lead to? So either it can lead to, uh, very uneasiness in the fish for the fish if it's one or two pellets. But if a lot of pellets end up in the gills, it can prevent the fish from breathing freely and circulating uh, the water, and then eventually it can lead to the death of the fish. And if we end up consuming the fish with pellets, we might also indirectly ingesting the fish. So yeah, so that that has happened there, and then the company that is responsible for it has to pay for these environmental damages that it has caused. So and the cleanup costs also. And yeah, let's look at how plastics. Let's look at a case study of a species, you know, which whose life is now surrounded by plastics itself. Uh, yeah, a lot of people might, a lot of you might have recognized this bird. This is none other than greater adjutant, which is is a species that is found in southern Asia, Southeast Asia, South and Southeast Asia, and in India it's found predominantly in the northeastern part of India, and then a small population is in Southeast Asia. So it's an endangered bird. The populations are very few. And where do you find this bird? In Assam, you see a huge population of these birds surviving well and good on garbage dumps. So that's why they have been changed. So these are mostly feed either in water bodies or wetlands. Once these wetlands are these days, these most of these wetlands are used predominantly for dumping of waste. So they have well adapted to live off these garbage. Not only adjutants. If you look, there are a lot of other species here. Let's just count the number of species. There is one here, the cattle egret. There are crows. There is this is crow. I think there are they might have you might have seen kites, and there are cattle uh, that feed ready in the garbage dumps. So it's not one species. Since I'm just focusing on this one species because it's species with conservation priority. So yeah, so that's the case with greater adjutant. So for us, we had to change the way how we behave in this environment for these species to exist. And then these species often die because of ingestion of plastics, and then their young ones are also affected because that's what they can feed. And let's just have a look at climate change in brief. So how do we knew that this climate is changing? Because we have been keeping up records of what carbon dioxide, which is one of the major greenhouse gases from 1960s. So we have proper sequential data that has been take, being taken up. So if you plot carbon dioxide concentration across years, it shows a graph like this that increases, decreases, increases, decreases. So this type of plot is called as Keeling curve. So it was named in honor of this person Charles David Keeling, who started this carbon dioxide monitoring program. And this thing, this curve kind of helped us, uh, say that carbon dioxide levels in the earth has been increasing regularly, and this is one of the regions that we are seeing increasing temperatures and other aspects of climate change, changing climate. And we all know that it affects a lot of other aspects of human life. Either it could be the water availability and food production. It can affect the health and well-being of humans. It affects cities, Most of these big cities leads to a flooding. They can be flooded. They damage infrastructure, and there is effect on biodiversity in the ecosystems also. For instance, you might have just heard of what is happening in Sikkim and what is happening in Himachal and Uttarakhand in August, September, July, August. So basically, a lot of rainfall in a short duration that lead to a lot of flash flood events, a lot of landslides, damaging infrastructure, endangering human lives, and then yeah, causing havoc. So most of these, at least we are witnessing in Indian context, we're witnessing in the Himalayas. It's not only Himalayas; there are other areas also, that are witnessing the effects of climate change. So yeah, most of these are due to humans. You know, and then so if you look at what are the effects that are going to happen, so increase in hot extreme events and uh, acidification of ocean is going to happen for sure, and likely there is a relatively likely chance of increasing heavy precipitation events across the globe on an average. uh, Most of the glaciers are going to retreat and there is a global sea level rise. There is a more or less medium amount of confidence in events like compound flooding and increasing fire weather or droughts. So IPCC comes up with these reports, which is a body, interpanel for climate change, governmental panel for climate change. I think, yeah, it comes up with assessments every 4 to 5 years, I think. And then the recent assessment was published in 2023. So what does it say? So if you are able to halt the warming of climate by 1.5 degrees Celsius, this is what you would say. Either in hottest day temperature, the extreme events, wettest day precipitation change are going to be mild compared to if you are not able to act and the temperature rises to 4 degrees Celsius. So the wettest day precipitation is like a lot of water rainfall just gets dumped in a single day in a single place. So that is what this wettest day precipitation says. While the hottest day is like one day is so hot, the degree change. So these plots are about degree change. So temperatures are going to get very hotter than what it was if you don't halt climate change. So what options we have? We have a lot of options, to reduce climate change. Uh, Basically, especially because we can using carbon dioxide as a gas because it's one of those greenhouse gases and is responsible for you know climate change. What we can do is we can try to reduce the amount of carbon dioxide in it so that we can reduce the effects it has on climate. One, what we can do is like we can directly capture carbon dioxide from the air, or from the sites where the carbon dioxide is produced, like factories or any other areas, and then we can store them, store the carbon dioxide. Or we can have afforestation or reforestation. You can plant trees, and you can extract carbon dioxide, or you can enhance weathering, or you can fertilize oceans by providing some essential minerals that are not available in ocean, that leads to increasing ocean productivity, that eventually captures uh, this carbon dioxide. So let's just talk about little while about carbon dioxide storage. So it's also termed as carbon capture and storage, or CCS in short. It refers to technologies that capture this gas, basically most majorly carbon dioxide, and store it safely underground, so that it does not contribute to climate change. And this carbon capture and storage can happen majorly. Uh, it can start from capturing from the large source emissions, or basically from the factories where the carbon dioxide is being pumped up into the atmosphere, or directly from the air also, source from source itself or from the atmosphere. you can have both. Capturing from the source, helps in reducing the effect the carbon dioxide that is emitted does, and it's also much more easier to capture from the source because the concentration of carbon dioxide is so high. But if you have to capture it from the atmosphere, it's going to be a difficult task because you have to you have to regularly extract the lower concentration of carbon dioxide from the air. So there are multiple process that happens. You have to capture, you have to transport, you have to storage, or you can also utilize the carbon dioxide, like physics or small scale industries. So CO2 capture can happen from the industrial plants, can be transported more. It's easy to transport it in liquid form because the volume also that you can the amount of carbon dioxide that you can transfer increases, and then it is generally injected into deep areas in the ocean or on the land. Just talk about how it's captured. So mostly cement plants or coal or gas powered plants, which are major emitters that can emit from a single location. You can set up this plan to capture the carbon dioxide from there itself. You can have absorption based methods where the carbon dioxide comes and get trapped onto a uh, specific material, and then you can, by heating or cooling or other processes, you can separate the carbon dioxide from that from the capturing thing. So once you're captured, you either mostly liquefy them and then you transport. You can transport it to these pipelines. If you are transporting from from the source to the shore, from there it can be transported by ships also, or even in the ocean you can have pipelines that can be transporting carbon dioxide. So for storage, what happens is mostly CO2 is injected into the deep underground rock formations. So almost more than 1 kilometer depth or more, where it is permanently and safely stored for longer durations. Or most of these rock formations where this is pumped into have tend to be these empty oil wells, where you have you had oil and gas, and that has held for millions of years, and then there's a high chance it will hold it if you just pump in carbon dioxide. And so it's basically you are taking up fossil fuels, and then you're burning them up. Whatever the carbon dioxide you're emitting, you're trying to put it back into this where you took the fossil fuels from. Somewhere around 300 million tons of carbon dioxide are already being stored in the oceans and basically underground, and there is a high storage across the world because we have been digging up for fossil fuels, so we have a lot of storage to store most for a lot of carbon dioxide. So where all can we store? You can store in saline formations like this one, or you can store in deep unminable coal areas, which is like 2 3 kilometers deep or 5 kilometers, which is it's unreasonable to dig. It's not easy to dig and uh, extract the coal, so you can have seal them there, or you can put them in oil and gas reservoirs, or you can just put them in empty gas reservoirs. Or what you can do is like you can pump in carbon dioxide in a currently extracting gas reservoir, wherein once you pump it up, since there is very little space, it will eventually you know actively push out the oil. So where it will might be easy technique for simultaneously taking out oil and then putting back in carbon dioxide. So it's already happening in the world, this carbon capture and storage. There are somewhere around 29 operating facilities, uh, which can together capture around 40 million tons per annum of carbon dioxide, and then putting it into these reserves. Uh, their operating capacity is like somewhere around to 8 million cars. The amount of carbon dioxide being emitted by 8 million cars equivalent is being taken off by these. So this is one such example. This is a power station in Canada. So they had this carbon capture and storage installed with it, and they are putting up this coal powered power plant. So yeah, so that's some of the things that we are trying to try to do in this changing world. So what we have altered a lot of stuff, and we are trying hard now, striving hard. We're not even striving hard to fix this. We're just trying. We need to strive more to fix most of these problems we have caused, and then altered the nature. Yeah, that's all for today. Yeah, if you have anything, yeah, feel free to ask in the comments. Yeah, thank you. Thank you for that. That's all for today. Thank you. Goodbye.